So we're going to start with the schematic extender. First thing we'll do is open up an existing schematic drawing. Now, as you can see, this is a rough schematic for a mini excavator. We've got a hydraulic pump, we've got pressure relief valves, we've got a pressure indicator, we've got 3 controllers, and we've got a series of rams attached to those controllers, each with their own relief valve. Now, we want to be able to generate a full schematic, or we want to extract all of the schematic information from this draft. So we've got a tool here, schematics, and we can extract all of the information out of, for example, the blocks themselves. Now there's 2 extra properties here. These are stored in those blocks and they show up, and you can include them or exclude them from your block list if as you desire. Next, you've got your table options. This controls where it's going to put the tables. We'll move on to our occurrences table. This allows us to select one or more block occurrences that we want detailed information for. For example, each of the pressure control valves that we've inserted, it prompts us to tell it what pressure that particular valve is going to be set for. So I want to now create a block or a table listing the pressures of each of those pressure control valves. And again, we've got all of the options for laying out the next table. Lastly, we've got the connections table. Now, this allows us to control how connections to a particular block are determined. We can use block range connections, that is, anything that falls within the block definition is considered to be connected to it. We can also use what's called block label anchor connections, and where, for example, you've got various pins on a component, you can give them names and it will determine which of the pins it is connecting to on that component. Now, some things like, for example, pressure, which is a label that we've got on the valve controls, we don't want to be considered as a block label connector, so we can exclude them or we can include ones that we do want. Lastly, you'll notice down the bottom here, with each of these blocks, I can choose to write the table out to a file, be it text or comma delimited text, of a particular name. And we get to choose which of these options we're also going to create. So we're going to just continue with this, and you'll notice that it's quickly generated the tables, and also in the line type definition, this is what this allows us to set different line properties meaning different things. So we can set up a key table. In this case, I've got that a 0.5 mm continuous black line or black-white line means it's a hydraulic 50 megapascal line with a diameter of 20 millimeters. Now, if I want to change that, it's quite easy. For example, I might want to change that to 18 millimeters. If I just accept this, it will go ahead and create that. However, if I want all of that type of line in the future to mean this particular definition, then I can update my line type library, and that will use that particular definition in the future as well. Now I'm just going to move that line type key over, and you can see it's given me a line type key, i.e. type 1, which refers to the type in the connections, and all of the connections in the schematic. Over this side here, we've got a full component list, and this has pulled out the mass and the stroke from each of the blocks has been used, and it's propagated them with that. Now we've also got the block occurrence table. We wanted the valve pressure controls and the pressure that each of them was set to. So you can see that one of them has been set to 31 megapascals, and the rest have been set to 35 megapascals. Now, what happens if we update this quite significantly? Well, we might want the bucket RAM to be a smaller RAM than all of the rest. So I'm just going to select that, right click, and I'll replace. I don't want to use the analog, I want to use a cylinder 3S. And you can see you can have different libraries as well. You can have the active document and a different library selected. I'll just use the 3S cylinder, and you can see it's a smaller part. Now I might want to update the layout of this as well. For example, this RAM, or the boom RAM, at the moment there's 2 boom RAMs. I only really want 1 boom RAM. So I'm just going to delete that connection, and I'll move this one down to connect up. All I've got, well, I'll move the title down as well, and then all I've got to do is simply hit update. It goes away, updates. You'll see it's added the cylinder 3S in there now. It's also reduced the number of cylinder 3s to only 2, and it's updated the connection table as well. So very, very quickly, once you've set up, it can handle the modifications that you might need as you go down the track. You'll note also it's updated the item numbers on all of the components. So that's just a quick look at this type of schematic extender, and some of the things it can basically just take away some of the time that you would normally spend. Now it has one other quite useful functionality as well. I can set up the schematics in my templates before I even start a document as well. So here I'm starting a new document based on my schematic template, and you can see that I have all of my tables laid out in this document ready to go. So we'll just start by creating from scratch an electrical circuit this time. We've already had a quick look at hydraulics, so this time we'll do electrics. And I'll just zoom in a little bit. I've got a battery, I'll place that. Notice it prompts me for the voltage as I place it. Next we'll put a motor in, and I'll place the motor down here. No values needed for that. If I wanted, I could add, for example, something like wattage, and we want a switch in there. Now note, I can bring these around quite easily. I'll just put my switch in there, and I'll put a resistor in for the sake of it. And again, with the resistor, it prompts me for a value. Lastly, I'll just throw a diode in there because we want this, oops, goes that way. We want this to not blow up or short across the switch when we turn it off. Then we'll just use, for example, a connector, and I'll make these black to start with. So you can see that it's quite easy to line up my connectors and flow them through. Now I might want different, size wire, and that can be represented by a different width or even just a different color. So now that we've got our circuit, we might want to move it around. You can see I've sort of made a bit of a mess of it. It's not very central, so I can just move my components around a little bit. So there we go. Now all we need to do, because we've already got the tables in there, is I just need to update. And you can see that it's pulling the different wires out of the library already. It hasn't filled in the connector or the capacitance table for a good reason. There's no capacitors in there. However, it's got all my quantities and all of the values of everything else. Now you'll notice here junction 2 is listed on this side connecting to motor item 2, and it's also listed on this side. This is a function called both connection directions, and you can turn it off if you don't want it. Then you just need to update, and you see the table update as well. We give the option for that because it makes finding connections to particular components very, very quick and easy. So that's just a quick look at some of the tools we've got for schematic connections.